Section 8.2 Trigonometric integrals. We are going to see how to integrate powers of sine and cosine and then powers of tan and secant. We'll start by sine and cosine, which are of this form. We are going to see three cases. In all the three cases, we are going to use the identity sine square plus cosine square equal to 1, which can be written like this, as sine square equal to 1 minus cosine square. This is how we are going to use it. Or cosine square equal to 1 minus sine square. We are going to use another thing actually from calculus 1, which is integration. If you have u function of x to the power n and you have u prime dx, then integration, as you know from calculus 1, is un plus 1 divide n plus 1. We are going to use this method of integration as well here. Case 1, if n is odd, which is the power of cosine, if n is odd, then we are going to hold or take one cosine out as 1 cosine dx and change everything into sine function using the identity cosine square equal to 1 minus cosine square, then use u and u prime. I think this can be seen nicely in the following example. Now here the power of cosine is odd, so we are going to hold or save 1 cosine x out, so this will become cosine square x sine 4. Then change the cosine square using the identity into 1 minus sine square. This is times sine 4, and this should be saved out and not to be changed. Then this can be simplified into sine 4x minus sine 6x if you multiply sine 4 by the bracket. This is kept out as it is. Now this is actually like this is u and this is u prime. So if we take u as sine x, and as you know, if u is sine x, then du is cosine x dx. So this integration will be like u4, because u is sine, minus u6, and cosine dx, which is this, is du, which can be integrated very easily by saying u5 divide 5 minus u7 divide 7 plus constants, and then replace u by sine. So this is sine 5 x divide 5 minus sine 7 x divide 7 plus constant. So if we look at the procedure again, the power of cosine was odd, and so we take 1 cosine out, we saved it out, so this became cosine square. So since it became even, we can use the identity and change it into sine. So we are going to have a sine function here, and this is a cosine, which is derivative of sine. So if we take u as sine, du is cosine dx, so what we have here is u4 minus u6 times cosine x, which is du. This can be integrated very easily simply by saying u5 divide 5 minus u7 divide 7, and then replace u with sine. Now case 2, if m, which is the power of sine, is odd. In this case, we are going to save out the sine x, and change everything into, or the remaining into, a cosine. Let us see. Now this is now the power of sine is 3. So we are going to save out 1 sine x. So the sine cube, the odd power, will become even, so we can easily change it into cosine. See, what we take out, we change. We have taken out the sine, we change the sine. So this will become cosine 4x, and this will become 1 minus cosine square x. This is saved out, not changed. Then this will become cosine, if you open the bracket, simplify this now, open the bracket, so this is cosine 4 cosine 6 sine x. So what we have now here, u and du. If you take u as cosine x, du is equal minus sine x dx. So you just need to add a minus here and minus there. So the integration can be written as u to the power 4 minus u to the power 6 du, which can be integrated easily by saying u5 divide 5 minus u7 divide 7 plus constant. Then u can be replaced by cosine 7 divided by 7 plus constant. Now it's very important to say at this stage that you see, when you have an odd power of a sine or a cosine, like for example here we have an odd power of a sine, so we have saved the sine x out. It does not matter what is the power of cosine, as long as we have an odd power, this procedure should work. If for example here the power of cosine is 4, it can be also the power can be half, which is the square root. It can be cosine to the power, for example, minus 3. That's okay. It can be fraction, it can be negative, as long as we have odd power of sine. Same thing apply for case 1. If we have an odd power of cosine, it does not matter what is sine. What is the power of sine? You can have, for example here, you can have a secant square x times sine cube. This can also be done because the secant square actually is a cosine to the power minus 2. So instead of power 4, it's power minus 2. But you can just put minus 2 here and just continue the same way. So as long as we have an odd power, that's the main thing. It does not matter what is the second power. Case 3, if the power of sine and cosine are both even. So we cannot save a sine or cosine out in this case. We have to use this identity, which is the half angle identity. For example, if you look at number 14 as an example, sine square, it will be written as 1 minus cosine 2x divided by 2. The idea is we are reducing the power from 2 to cosine to the power of 1. So we have integration from pi divide 2, from 0 to pi divide over 2 dx, and you can integrate this very easily. You can bring the half out, so you have integration of 1 minus cosine 2x dx from 0 to pi divide 2, which can be integrated simply by saying x minus sine 2x divide 2 from 0 to pi divide 2, which is equal, you can replace now the pi divide 2 minus the 0. So this will become pi divide 2 minus sine pi, 2 times here, pi over 2, which is 0, and then 0 minus sine 0, which is 0. So the final answer will be pi divided by 4. Another example for the even powers is sine to the power of 4, which is, it can the technique I'm going to do now, it can also be used to integrate sine square cosine square. Both powers has to be reduced using these identities. So here what we are going to do, we are going to say 0 to pi, let's keep the 8 out. Sine 4 can be written as sine square x square, or sine square times sine square. So sine square is equal to 1 minus cosine 2x divided by 2 square. This 2 square, which is 4, it will come out as 4. You can square the bracket, so it will become 1 minus cosine 2 cosine 2x plus cosine square 2x dx. So this is 8 divided 4, integration of 1 minus 2 cosine 2x. Again, you have to change cosine square into 1 plus cosine 4x using the same identity, but instead of 2x you have to double the angle. This will be divided by 2 from 0 to pi. So this will become 8 divided 4, and this is minus 2 cosine 2x. This is 1 plus half here, which is equal to 3 over 2, plus half cosine 4x dx from 0 to pi. So this is equal to 2. Integration now is minus 2 sine 2x divided by 2 plus 3 over 2x and plus 1 over 8 sine 4x from 0 to pi. Replace pi and then 0. So it will be sine 2 pi, which is 0, plus 3 over 2 pi and plus 1 over 8 sine 4 pi, which is also 0. Then sine 0 is 0, and here x 0, everything here is going to be 0, and final answer will be 3 pi. Now this is integration of powers of secant and tan, or cotan and cosecant, which are of these forms. The technique is similar to powers of sine and cosine, except here we are going to save out the secant square x, which is derivative of tan, so we are going to change the remaining function into tan and integrate using u and du, or we are going to save a secant tan out, and this is derivative of secant, so we are going to change the remaining function into a secant, something to do with secant, and integrate. We are going to do this using the identity, or we are going to use the identity tan square plus 1 equal to secant square in order to change it from tan to secant or secant to tan. Now, we are going to have 4 cases. Case 1, when n is even, which is the power of secant. When n is even, we are going to save a secant square out, which is like this, and change the remaining function into a tan, and then use u and du. Let us see this using the following example. See here we have the power of secant even, which is 4, so it's even number. So we are going to hold out or save a secant square out, and because the power of secant is even, it will remain even because we have taken a square out. Then, now this is derivative of tan, which means secant square will be changed into tan. You see, like we said before, whatever we take out, it is the one we change. We have taken a secant out, we are changing secant into 1 plus tan square times tan square. This is saved and changed as a du. This is going to be expand, open the bracket, plus tan 4 x secant square x dx. Now we have u and u prime. Tan, this is u and this is u prime. So if we take u as tan, du of tan is secant square x dx. Derivative of tan is secant square. Now, so this will be equal to u square plus u4 du. This is du, which is here. So integration of this can be done very easily. u3 over 3 plus u5 divide 5 plus constant. And then tan, or u, can be replaced by tan, which is tan 3 divided by 3 plus tan 5 x divided by 5 plus constant. Now case 2, when m, which is the power of tan, is odd positive integer. In this case we are going to save secant tan out. and then change everything into secant. Let us see this example. See here, the power of tan is odd, so we are going to save out a secant tan. When a tan is saved out, this is tan. Let us change this. This is tan x. So the remainder will be secant square tan square. Now this is derivative of secant, which means everything has to be changed into secant. So tan square will be changed into secant, which can be done because the power now, the remaining power is even. So we can change this into secant square x minus 1. This is secant tan. And open the bracket, so you have secant 4x minus secant square x. This remain as it is because it is going to be used as du. Now if we take u as secant x, this is now like u and this is du. So if we take u as secant x, du as secant tan, because derivative of secant is secant tan. So this integration will become u4 minus u square du, which can be easily integrated as u5 minus u3 plus c. U can be replaced by secant minus secant 3 plus constant. Case 3, if we have tan only, no secant to the power m, which is a positive integer. Then we do the following. For example, if we had tan to the power 4, then we always separate a tan square and write the remainder. What is remainder in this case? Remainder in this case is tan square. Then what you have separated, you change it into secant square minus 1. So you have tan square here, and then you have tan square, you open the bracket, secant square, which is u and u prime, minus tan square. What happened here? We'll end up with tan square x secant square, which can be done very easily, minus integration of tan square. So the power of tan has been reduced, and we can continue in a similar way. So tan square can also be done again using secant square and so on. Integration of the first part, this is u and this is du, so integration is tan cube divided by 3 minus, again use secant square x minus 1 dx, which is equal to tan square. So this is tan cube divided by 3 minus integration of secant square is tan, and integration of minus 1 is minus x, but there is a minus here, so it will become plus x plus constant. Case 4, f secant to the power n when n is odd. You see, when n is even, you can only separate secant square x, and then when it's even, the remainder will be even, and you can change this into tan. For example, if it was secant to the power 4, this will be secant square, you can change it into tan. But when it's odd, for example, secant cube, if you take a secant square out, if it was odd, the remainder here will be odd. You cannot change it into tan, so you cannot have a udu. It has to be done by parts only. So you take u as secant x and dv as secant square, because it is easy to integrate secant square. V is tan x, and du as secant x tan x dx. And then integration by parts. Let's say secant cube x, which is u dv, is equal uv minus integration of v du. So you have secant x tan x minus integration of secant x tan square x dx. This is equal to secant x tan x minus, you change tan square into secant square x minus 1 dx. This is equal to secant x tan x minus integration of secant cube if you open the bracket, and secant times 1, so it's going to be plus integration of secant x dx. This is actually similar to what we have on the left hand side, so we can transfer this to the left hand side, so it will become 2 secant cube x dx equal to secant cube equal to secant x tan x plus integration of secant x, which is ln secant x plus tan x plus c. So integration of secant cube x dx is going to be 1 over 2, which is this, times all of this. So this is the final case for integration of powers of secant and tan. But we must say one thing here before we end this topic, as to integrate really secant tan, a combination of secant tan or tan alone or secant alone to the power. Okay, we don't have to memorize all of what we did now, like if powers of secant is even, you take a secant square out, or if the power of tan is odd. You don't need to memorize all of that really. You can just try to separate a secant square out, which is derivative of tan, which means you have to change everything into something to do with tan using the identity 1 plus tan square x equal secant square. You can only change secant here into tan if the power of secant is even. If not, you try this. If you try to separate secant tan, which is derivative of secant, so you must change the remaining function into a secant. If this is not possible, if that could not be done, and this one also could not be used, then it has to be done by parts. Now, the last part of section 8.2 is integration of sine, cosine, products also of sine, cosine to the power of 1 each, but with a different angle. In this case, cosine is not derivative of sine because you have different angles. So you will have to use these identities, which you need to memorize. Let us see this example. We have sine 2x cosine 3x. You see, in this case, cosine 3x is not derivative of sine 2x. Otherwise, it will be done using u and du. So this is a, this is b, the 3x is b, and the 2x is a. And I'm going to use this identity, which is sine cosine. So it will be integration of 1 divided 2 sine a plus b, which is 5x, plus sine a minus b, which is 2x minus 3x, dx. So this is a and this is b, this is a plus b and this is a minus b. 1 over 2 can be written outside, and you have sine 5x minus sine x. Keep in mind that sine minus x is equal to minus sine x, and cosine, so raise this, sine minus x is equal to, and cosine minus x is equal to cosine x. So the sign becomes minus out, the cosine is just a plus. Anyway, so this is now minus sine x, which can be integrated very easily simply by saying minus cosine 5x divided by 5 and a plus cosine x, a plus constant.